Okay, last little piece in this section is experimental error. So this is not one of the two kinds of error that's talked about in a lot of numerical methods classes, because this, or textbooks, because this is not technically a numerical error. This is something that happens in the real world with not 100% perfect sensors or other modes of measurement. And the reason why that's important to us in the class is because when we get to the last couple weeks of class, we're going to actually do what's known as regression, or we're going to be fitting like lines or other models to data. And when you do that, you have to deal with experimental error, right? So, for example, you have 2 points. Let's say you have 2 points, 2 measurements, and you want to fit a line to the measurement, right? So the question is, can you fit a line from 2 points? And the answer is yes, of course you can. But not if you have noisy data. If you have noisy data and you only have 2 points and you're trying to fit a line to it, your slope is going to be, and your intercept will both be completely wrong. So consider this set of data that I have here at the bottom, and I have more than just 2 points, right? And clearly there's some sort of linear-ish relationship to this set of data, these x and y values. But let's say I only had 2 of these points. Pick any 2. I mean, if you pick any 2, let's say you pick that one that I just circled and this one, maybe that's as close as you're going to get to an actual line. But if you pick pretty much any other 2, you're not going to get anywhere near the right answer, especially if you pick like these 2 here, or even these 2. And so when you have experimental error, you need to have some way of dealing with that. When you're fitting your model, or in this case a line, to data, then you calculate something known as the residual. The residual is effectively your delta y, your difference between your data point and what your model says it should be at that point. And that residual, you're trying to minimize the sum of the square of all the residuals in order to get your best fit line to your data.